This is lesson 4.1. It's about graphing quadratic functions and then doing transformations. You can see here the lesson objectives, and so we will begin. The parent quadratic function is the function f of x equals x squared. So if we want to graph this, we could pick various x values and square them to get the y values, and then we could graph them. So if x is negative 2, y would be 4. When x is negative 1, y is 1. When x is 0, y is 0. And we get 1, 1, and 2, 4. Once we have the points, then we can draw a curve through the points. And that is what the parent function looks like. This parent function has some features. First of all, this graph is called a parabola. And the parabola has an axis of symmetry. The axis of symmetry for the parent function runs through the line x equals 0, and you should know from geometry that symmetry means you have some mirror imaging. So the left side is a mirror image of the right side. The parabola also has a point that's either the lowest point or the highest point on the graph, and this point is called the vertex. In this case, for the parent function, the vertex is at the origin, 0, 0. If we wanted to graph a function that was slightly different from the parent function, like f of x equals 1/2 x squared, in the order of operations, we would first square our x values and then multiply them by 1/2. So in this case, when x is negative 2, y is 2. When x is negative 1, y is 1/2. When x is 0, we get 0. And then we have our symmetric points on the right side of the graph. And we can draw the curve through these points. This graph is a compression of the parent function because the values that we would expect to be, like, say, when x is 2, y is 4, that point has been pushed down to 2. And it's been actually pushed down, so it's half the size that it should be. That's what makes it a compression. If this a value, instead of being 1/2, if it were a larger number like 3, then that would be called a stretch. We can also graph transformations where the graph slides instead of just compressing or stretching. So in this case, we have x squared minus 5. So in the order of operations, we would first square the x value and then subtract 5. So what ends up happening to the graph is the parent function gets translated down 5 units because after squaring, then you subtract. So everything just goes downward. Another transformation that could take place is one like this, where you have x minus 4 in parentheses. So in the order of operations, we would subtract 4 first and then square it. That transformation ends up making your graph go to the right 4 units. And I know it seems unusual that it would go to the right, but if you try some calculations on your own, you will find out that it actually does go to the right. For example, if x is 0 in the parent function, we would have a point at the origin. But in this transformed function, when x is 4, we get 0. So that's this point here. In the parent function, when x is 1, y is 1. But in the transformed function, when x is 5 is when we get 1. 5 minus 4 is 1, and then square it. So you can try that out on your own. Okay, so these are the main things that we should get from a translated function. We should be able to find the vertex. And in this function, we have a transformation that would go left 1 and up 4. So that transformation moves the vertex away from the origin, left 1 and up 4. So the vertex is at negative 1, 4. And the axis of symmetry would run right through the vertex, equal to the x value. So the axis of symmetry is x equals negative 1. The maximum or minimum value will occur at the vertex, And the minimum value in this case, it is actually it's a maximum value because our a value here is negative. So it's going to be a maximum value, and it is the y value. So our maximum value is y equals 4. So if we were to graph this function, we would have a vertex at negative 1, 4, right there. And then the negative 2 tells us that the function is going to stretch and it's going to flip over, so it's going to go upside down. We're going to get a graph that looks like this. So the domain to this function is all real numbers. The range to this function is all real numbers where y is less than or equal to 4. And that is an introduction to lesson 4.1.